Hello everyone, this is Aaron. Matt and I are going to take turns putting out a short podcast episode that wraps up the previous week and looks ahead to the readings and topics in the upcoming week. I'm not sure if we'll do it every week yet. We might just do it as needed, but I'm going to start us off. In the first week, we read the Siemen's article that gave an overview of learning analytics. You also watched a short video on big data. For me, Figure 1 on 1387 was important in showing all the influences of learning analytics, building on techniques and applications such as social network analysis, knowledge domain modeling, personalization, user modeling, and so on. The article also discussed the concerns that the field has to address in the latter part of the reading, not just relating to privacy, which many of you brought up, but also the implications of the mechanization of human behavior and social processes. For me, I think the question that's not directly addressed is that we have all this data that exists in the world. What can and should we do with it? The danger that Siemen mentions on page 1395, the danger of turning human behavior into algorithms, is that these algorithms, if they are created and if they are deemed legitimate by whoever has power, this takes on a life of its own, regardless of whether the algorithm can handle the situation accurately. You'll see an example of this in week 4 when we discuss ethics. One thing that caught my attention in the Siemen's reading was when he writes on page 1387, quote, "The expansion of data beyond SIS and LMS into a broad range of sources, including the physical interactions that currently do not leave data trails, is important in increasing the quality and depth of analysis," unquote. He then goes on to describe wearable devices and other things that passively collect data. That was what motivated me to pose the question about what information you would be willing to share to the instructor for the sake of your learning. Xingye brought up the point that she was willing to share activity data related to learning, but not activity unrelated to learning, like playing video games. And I think I responded saying that companies often infer things about us based not just on what they collect directly, but also indirectly. I added an article under the optional reading section on how Target accurately guessed a teenager was pregnant based on her purchasing behavior before even her parents knew. Now, there may be some confirmation bias here. We don't hear all the times a company guessed incorrectly, but that I think is the underlying issue. It's disturbing when an algorithm is too smart, but it's problematic when it's not smart enough as well, especially if you're relying on it to make decisions. Siemen also mentioned something about the quantified self. I don't know if any of you are familiar with that. I listen to a lot of podcasts, and one genre of them is productivity. A lot of these podcasts discuss being aware of what you do, and this often involves quantifying your behavior in some way. The most obvious example is time tracking. I used to have the software installed on my computer called Rescue Time, and it would track all the things I do on the computer and tell me how productive I was. And I literally just unsubscribed from that, not because I think that type of thing isn't useful, but because I was gaming the system. Another example would be fitness tracking, measuring how many steps you took, how active you were, how many calories you consumed, even how well you slept. All these are data points that do have some value. Remember in the video at around the 3-minute and 12-second mark, the host talks about a study of 58,000 Facebook users. The study found out that, for example, if someone liked thunderstorms, science, and curly fries, they are more likely to be highly intelligent. I've put the article under optional readings in case you want to check it out. It's only 4 pages. This study isn't unproblematic. I think any kind of study that involves intelligence tests is at least suspicious, but assuming that it's accurate enough, then to go back to my question on slide 8, that would mean I have to collect a lot of data, even if they're not directly related to the class, in order to establish whether these correlations exist. And in that question, I was wondering where each of you would draw the line. Looking ahead to week 2, you have a reading by Ryan Baker. Matt was actually the one who found this reading, so I was reading it for the first time myself, and I really like the idea of a stupid tutoring system, in part because we tend to append the word smart or intelligent to new technologies, like smart homes and smartwatches, as if somehow the smartness or intelligence of the system is independent of who designed it and who uses it. But the idea of stupid tutoring system is not just a whimsical turn of phrase. It also aligns with how I tend to think of educational technology in general. I think technologies are great to do things that either I can't do or will take too much time to do. In the case of learning analytics, technology can help me collect, organize, and make sense of a large amount of data points. For example, all the things you do on Moodle, everything you clicked, every page you visit, the time of day of the week, all those are data points, but it would take too much time for me to collect it individually, let alone make sense of it if I didn't have some system to help me. And that's something you'll learn how to do in week 3. The Baker reading also reminded me of an article by Diane Forsyth, which I also put in the optional reading section. The Forsyth article is about expert systems instead of tutoring systems, so it's not exactly what Baker is describing. Instead, it offers another layer of complication to what knowledge is and the challenges of turning knowledge into a stable, coherent system of rules. Forsyth is an anthropologist, and in their article, she was a participant observer in an expert systems laboratory, where knowledge engineers were trying to capture knowledge from experts in order to codify them into an expert system. She describes a lot of challenges in the process, which I won't go into in detail, except to say that one argument she makes is that knowledge can't readily be codified into rules that can be turned into a program. This is similar to the mechanization of social processes issue brought up in the Siemen's reading. Think of natural language processing, which involves trying to create a program that can process the way we humans naturally interact with one another. But language isn't just about grammar. There's tone, there's context, there are nuances that can't easily be translatable into logical rules, things like jokes and sarcasm and irony and puns, for example. To understand those things requires a human understanding, which is where I see the tie with Baker's article. Baker's idea of having stupid tutors and intelligent humans means that we can complement things technology does well with things that humans do well. A technology can alert the instructor to a student who is consistently behind so that the instructor doesn't need to check all the time. This still leaves the decision on whether to act on the alert to the instructor. So that wraps up my podcast for this week. I hope you're enjoying this class. If you have any questions, you can email Matt, and I will talk to you soon.